Okay, so we're going to talk about robots and the work envelope. All right, this is a Cartesian coordinate robot. Okay, it has usually a column, an arm, but we usually call it an XYZ robot. Okay, or you may see in your book it referred to as a LOO. Another classification is a LLL. Okay, so this is a Cartesian coordinate robot. All right, so the x-axis is lateral, the y is longitudinal, and the z is vertical. All right, so it's going to give you the three axes, and it's going to have 3 degrees of freedom. All right. And so usually they're called gantry robots, and they have this rectangular shaped work envelope. Okay, and we say a work envelope is the area in which a robot works or where it can reach. All right. So this shows you another type of Cartesian coordinate robot. They can do things like arc welding, handling at machine tools. They can do assembly operations. They could apply sealants. They could do a pick and place. All right. Cylindrical coordinate robots are similar to the Cartesian. Okay, they have a column and a base, but the column can rotate. All right, and so a lot of times we call this an LRL. Your book calls that a, let's see, what does it call it? A TLO. All right, don't worry about that. Just understand the work envelopes for them. All right. Okay, so the r-axis, it rotates around the z. The base rotates. Okay, y is going to give you your longitudinal motion in and out. All right, and z is going to give you your height. All right, and so this is what their work envelope looks like. So look, it's a donut. It can't reach all the way in because it's got this part too. So, but remember, there's a dead space in this donut. All right. Okay, so they can do assembly operations. They can do handling at machine tools. They can also do spot welding and handling at die-cast machines. All right. A polar coordinate robot has a rotary base, an elevation pivot, and a telescoping extension, and also the retraction boom. Okay, we're calling this RRL. Okay, and your book calls that TRL. Okay, but this is a polar coordinate robot. All right, so here it's showing you the moments. Okay, on the r-axis it's rotation around the z-axis. All right, the p-axis is rotation around the x. Okay, and then y is its longitudinal motion in and out. Okay, that's what this looks like. Now see, again, there's a dead space inside it can't reach. So it kind of looks like this sphere with the top cut out. Okay, so you can come and see its work envelope. All right, they can do handling, spot welding. They could handle at die cast. They can do gas welding. They can do arc welding. Okay, they have a variety of applications. All right, jointed arm. All right, this is the type you're using in class. It resembles a human arm. It has human-like characteristics in that way. Usually on the rotating base, which ours is, the SCORBOT is, has an articulating shoulder and elbow joints. Okay, sometimes this is called RRR. Your book calls that TRR. All right, all kinds of coordinates about that. Okay, so at the base, all right, then we have the shoulder, the elbow, the wrist. Okay, and so you see that this is more degrees of freedom here. All right, and it is named just like the human arm. So the bottom, it's opposite, but the bottom is the elbow. is the shoulder, then here we have the elbow, then here we have the wrist, then of course off from the wrist we have the end effector. Alright, and so they have this spherical work envelope, but most of them do have a dead space in the back. They can't rotate a full 360 degrees, as you've noticed with the score box. Alright, they're used in assembly operations. They do die cast handling, they can do gas welding, arc welding, spray painting, they can do all types of things. This is a drawing of a ABB type robot, I think. Alright, and you can see kind of the examples on its axis, okay? So the base usually has at least 270 degrees. Alright, and there's variations on how much rotation you can get at each joint. Usually the wrist will roll, you know, somewhere around 2 full revolutions. A SCARA, okay, that's a selectively compliant articulated robot arm. Alright, and so they have this rotation there. They have vertical from the arm on the end, see at the end effector, okay. They have 2 rotations at these joints to create their in and out motion, okay. So they have this spherical wrist, and so they have 6 degrees of freedom, and they let it be positioned in any way. So that's what makes the SCARAs popular. All right, and so they have this. I always think this looks like a little comma, sort of. And they have an irregular work envelope because of that. All right, they do a lot of pick and place, and they do a lot of assembly operations are done with SCARA robots. All right, applying sealants and handling are fine, but oh, excuse me, I'm so sorry. They do a lot of assembly operations. Okay, so here I gave you this little slide, and it's on the PowerPoint I'm going to upload. That'll show you, that'll match the work envelopes for you, okay, because you need to be able to do this. Alright, and so you can click through here and go through these to review them. Alright, then also you have this slide you can look at to study too. I would like you to pick the operations that can be completed, okay, by different types of robots. Alright, so take some time, go over those things. You can see those in your book also. They are in section 8.12, alright, and 8.13. Thanks. Have a good one.